Ladies and gentlemen, a very good evening. I'm Antara and you're watching Point Break. India has been talking about semiconductors for years. Now it is spending on them. The Union Cabinet has approved Semicon 2.0 with an outlay of rupees 1.27 lakh crore. 12 manufacturing projects worth more than rupees 1.64 lakh crore have already been approved under the first phase. Micron, Kaynes Semicon and CG Semi have already started commercial production. The Tata PSMC Fab in Dholera, India's first major commercial silicon fab, is now expected to come online in 2028. Now that is real money and real projects, viewers. The announcement phase is over. But approving plants is easier than building an industry. A fab that gets built is not the same as a fab that runs profitably. Now, a packaging facility is not the same as an advanced packaging ecosystem. Design talent working for multinational companies is not the same as Indian-owned chip IP. The central question of Semicon 2.0 is not whether India can build semiconductor plants. Rather, it's about these individual projects that can, whether or not they can connect into a globally competitive ecosystem, or whether India ends up with several subsidized facilities that still depend on foreign technology and imported materials and overseas customers. That is essentially our topic today, ladies and gentlemen. I'm Antara. This is Point Break. Let's get right into it. My guest today sits at, I believe, the exact center of the story. Navin Bishnoi is the newly appointed Executive Council of IESA, the India Electronics and Semiconductor Association, India's apex industry body for the electronic system design and manufacturing sector. He, in fact, has over 25 years of global experience across semiconductor design, EDA, and infrastructure silicon, having held leadership roles at IBM, Freescale, Cadence, and Texas Instruments across AI, cloud, networking, and automotive domains. Navin, it's really, really good to have you on Point Break. Very warm welcome to you.
Pleasure to be here.
All right, let me start with a very honest version of where India is. 12 projects approved, 3 in commercial production, rupees 1.27 lakh crore committed. Is India's semiconductor story now about execution? Or, Naveen, would you say that we are still largely in the announcement phase with just better numbers? What is your stand on that?
Great start, Antara. India's semiconductor journey is no longer about whether we can enter the industry now. We have already crossed that threshold. The question now is whether we can build what we call India to be an equal partner, which means a globally competitive, sustainable ecosystem, and that can generate value beyond the incentives that we have. So you're right, the semiconductor success is not measured by a fab announcement. It is indeed measured by what we call as an ecosystem depth, the technology ownership, the supply chain capability, the talent, and global competitiveness. So we should celebrate the progress. We should not, or maybe we should also be precise about what has been built. Semiconductors are not one industry. A silicon fab, a compound fab, a specialty fab, the packaging facility, the design IP, EDA. There are different roles in the value chain. So India's real achievement is that we have finally moved from discussions to policy announcements to physical assets or fabs, production lines, and ecosystem creation.
So it's certainly an optimistic place to start, you would say.
Absolutely, it is.
All right. Naveen, I also want to talk about what does Semicon 2.0 actually change? Because the first phase of India's semiconductor mission was, largely about getting manufacturing units approved and under construction. Now, Semicon 2.0 expands that scope, right? Chip design, equipment and materials and additional fabs, advanced packaging, R&D, talent. It is essentially trying to build the whole value chain and not just, I would say, individual plants. So, Naveen, does Semicon 2.0 actually address the most important gaps that were left by the first phase? Or would you say it is sort of expanding the footprint before the first phase has really proven itself?
Yeah, I would call it we were expanding it. The first phase focused on the biggest gap that we saw it existing, that we had no manufacturing capabilities other than the small setups that we had in Chandigarh or a few other government organizations. but it did had a manufacturing footprint. It did had a design incentives. It had a talent program, and it was also surrounded by the ECMS and the PLI and other schemes as well.
Hmm.
But when we looked at setting up those first foundations of a fab and a packaging and others, the second phase we were looking at is that how do we create the overall supply chain or the other, I would say, the industries or the partners around that system. And that's where we looked at saying, hey, what are those? The chemicals, gases, the materials and equipments form an equal opportunity as well as a challenge. And how can we create that ecosystem? We also said that when we looked at design, our first phase was with the first kind of a project with the first, I would say, some certain incentives. But we also wanted to ensure that this goes beyond into a much more wider areas. So first we were looking at saying what are those commercial areas where these chips can come in, but we also wanted to serve our strategic areas, which could come from some of the mission critical situations or use cases, and hence we expanded and also wanted to expand saying if we go into some of the advanced node use cases, it will be much more than those couple of $1 million incentives and the other support that was there. And then similarly, we started expanding. And third thing, which we also recognized, that currently many places the technology is licensed. It's bought from some other technology partner from across the globe. But when the next generation transition we do, we need to build some of those technologies here. So also we put a focus on R&D. So if you look at it, expanded, accelerated, and ensure that the whole ecosystem comes in as part of the Semicon 2.0 proposal.
Sure. Naveen, something that also I want to ask here is, should the government prioritize completing existing projects before approving additional fabs? And I'll tell you why I'm asking that. Because I believe there is a risk of spreading attention and capital before, the first wave has really demonstrated commercial viability. So where do you land on that?
I hear you. I think, right, where focus versus expansion at the same simultaneous time. What I would look at it is that if we were at 0 out of 12 plans in execution mode, I would have agreed with you, right?
Okay.
But what has happened is that 3 are already in production. There are others who will get started this year and then next year and then 28. By 28, all of this will be operational. And you saw that this program was launched 4.5 years back. So it take a lot of time to go and evaluate the new projects, and it's a lot of evaluation, including the technology capability. So I would say the policy being there and initiating the evaluation of the next set of projects will go parallel with this execution. And by the time we start hearing some of the other new projects getting approved, we would have probably crossed that 50% mark of some of these programs being ready and into the production line. The reason it's also important is that because a lot of these projects was manufacturing centric, right? And in manufacturing, you'll have to fill the fab or the plants by two ways. One, you become part of the global supply chain. But the second one is that you create a local demand. And then probably we can talk about that a little later. But when you create those local demands, you need to have these process ready. But how do you create local demands? Is you create more startups and the design startups from here. We need to accelerate that as well as we move forward with that.
Okay.
So I think we reached at a right place to ensure that the first ones are moving fast towards completion and getting into the production, while the next phase is announced for us to start evaluating and start prioritizing the next set of things for the ecosystem expansion.
Understood, Naveen. Naveen, what outcome would distinguish Semicon 2.0 from another manufacturing incentive scheme?
For sure, I would say the biggest priority, we have talked talent, we have talked manufacturing, we have to really talk product creation. And when we say product creation, how many fabulous startups starts creating IPs and chips and products that can leverage some of these manufacturing ecosystem in India or globally and be able to bring out products that's available for deployment globally. That's one.
Okay.
The second one would be is that how quickly we start into the R&D, whether it is so all of packaging, if we take an example. All packaging branch is more on the legacy or the matured technology. But some of the use case that's coming in will need advanced packaging. It needs a lot of R&D capabilities. So how many technologies we are able to build here so that these large manufacturing companies can license it and leverage it locally? How many startups that we create? Our charter was to create 100. We saw 24 was successfully included in DLI 1.0, and also there were others who got some level of support. How do we go from this 24, 25 into 100? So I think those two will be the key metrics that we will look at, along with probably having the third one, which I would say is that what are those top 5 or 10 commercial or strategic areas that we can identify and ensure there's a demand creation, so that we are not stopping at IP or product creation. We are not stopping at just manufacturing and creating a product, but it can actually go into an end market and then start generating commercial value for these organizations.
All right. All right, Navin. Navin, let's also talk about what's actually operational right now, right? Micron, Kaynes Semicon, CG Semi have essentially commenced commercial production. Now, the rest of the 12 approved projects are at very different stages. Some are in construction, some are still in early development. Now, there is a real distinction between, a project being approved, being built, being commissioned, and actually producing chips at commercial yields and volumes. Naveen, how many of the 12 approved projects are producing commercial volumes right now? I'm not talking about the pilot runs, not validation batches, but actual production. And also what domestic value is being created, by the 3 operational units.
Yeah, for sure. The 3 that we know about is into the production already. As you understand, the Micron plant is for their own captive use cases. It's for their own supply chain of their product line. So they are already in production, working for their own products. And the 2 which are commercial, I would say, available for a larger market for use is the Kaynes and the CG Semi. And then both had the first customer. They have started delivering the production packaged parts to those. So both have started getting into what we call as a production one. The measure that we'll probably have to track, and I don't have the visibility inside into that, is if you have the capability of some number of wafers per month, right? How much of that has been secured and hence your production line is 100% occupied or something less than that? I think that's something that we'll slowly get to know. As I speak with the leaders from many of these organizations, they have been having great success working with a lot of global companies to sign MOUs, have some orders, and start doing that. And I think we'll probably start seeing a more open and public success stories coming out of that. So it's in production. I don't know whether it's probably we have to ask those companies about is it 80 or 100 or something else.
All right. Thank you for answering that, Naveen. Naveen, there's also something else that I want to ask you here. Should the government be reporting approvals in construction, production, yield, and exports as separate milestones? Because, right now, everything gets reported as a single number. And quite honestly, it's hard to know what is real.
Correct. Yeah. So I do agree that we need to start separating for 2 reasons. One, for the larger, I would say, ecosystem to understand what's the difference between these phases that we are talking about. Yeah. Because otherwise everybody starts, confusing between the terminologies, the words, the status, and the milestones. The second one is for us to be able to measure what we call as the value creation that we are able to do, the amount of commercial success that it's happening, the number of jobs it's creating, the amount of what we call as leverage that we are able to do with the global ecosystem versus global ecosystem. And hence, a lot of those metrics are needed for us to start measuring that. Okay. And then that's something probably, yes, we have been talking to the government. They do understand that. I believe they have an internal dashboard where they are actually tracking a lot of those details. but I haven't seen a public version of that to be disclosed to everyone out there. But I do agree that is something that will get visible for us to start tracking really and then saying that, hey, the ecosystem is really maturing with this much percentage of global versus local and the value creation.
All right, all right. Naveen, what information should government publish so progress can be, independently evaluated? Because IESA is the apex body of the industry, and you are essentially setting the standard for what transparency really looks like. So, where do you stand on that?
Yeah, I would say that there is definitely some level of metrics that needs to be done. And then probably I'm building on from what I said in the last question as well, right? We need to know what we said is that local versus global value chain, the supply chain, the value creation, the commercial, the percentage of, the number of wafers that you signed up or the capacity that you have built in, but also on saying, how much is what kind of industry verticals that you are supporting, right? Is it an industrial use case or an automotive use case? Is it a data center use case or a consumer use case? Some of those are equally important because that will start tying up to the end market and the end product companies for them to start looking these companies as the alternative to some of the other global suppliers. Along with that, I would also expect that it would probably start mapping it with the efficiency of what it takes, whether it is a dollar, whether it is a cycle time, a minute or something, for us to process these number of wafers and then being able to say that we are globally competitive with respect to many others as well. Now, some of these does global companies publish? Probably not all the time, but somewhere maybe at least till the time government incentives is plugged in, should track it. Publicly available, maybe not, because there's a lot of what you call as a progress that happens as the technology matures and company goes through that cycle. So they may or may not choose to publicly publish that, but maybe at least publish to the government.
Okay, understood, Naveen. The Tata PSMC project is also something that, everyone is watching very closely. Now, the Tata Electronics PSMC facility in Dholera is scheduled to be commissioned in 2028. It will be India's first major commercial silicon fab, wafer fabrication and not just packaging. Now, everything else can be running well, but if this project stumbles and fumbles, it changes the narrative entirely. What really happens, and rather, what has to happen between construction and this fab reaching commercially viable production? Because, commissioning a fab and then running it profitably are two very different things.
True. The way you look at it, and any of these large fabs have been set globally as well, right? While the construction is happening and all of that, right? You need to have the customers who can sign up for this. But for customers to sign up, they want to look at the technology that is being offered, right? How mature those technologies are, have they been mapped to what we call as, the use cases that we have been looking at for these customers. The second thing comes up is that when the building comes up, how does the infrastructure inside the four walls comes in? So what kind of machines and equipment comes in, and how are they calibrated to match with this technology and the machine operations to be able to generate the output that we need, because this is a very highly specialized and very focused area of fabrication. And then third one is that do we have the right talent pool from start to end for them to be able to take what we call as a design entry and then take it through the processing, through the manufacturing to a wafer, and then being able to deliver to the customer. And then hence you need a lot of processing, which is sometime engineering, sometimes the factory operators and many other things. And then being able to do that. And then third one beyond that would be is that once we have delivered this, how do we work with the customers based on the feedback of saying what kind of performance, the yield, and the supply chain logistics and everything else gets tracked, so that this actually becomes a really same supply chain, that the design entity gets finished, come to these fab, and then goes out and then meets the cycle time of the product launch. So those are some metrics for us to be ready in parallel while the physical infrastructure or factory gets ready.
Got it. Naveen, can Indian demand really sustain a large mature node fab at consistently high utilization? Because utilization is where economics either works or they don't, and you can't really run a fab on subsidies forever.
Absolutely. Absolutely. Uh, can India create demand? Yes, means I
Okay.
think the amount of usage that we have is significantly the amount of import that we see getting published through different reports and an use case. Definitely. The challenge remains for us is that is there an Indian company which is focused on creating those products from here, not just for India demands, but for the global demands, right? None of this will make sense if we focus only on India demand. It
Fair.
has to be a global demand serving, right?
Right.
But India demand needs to be covered as part of that as well. And then hence one of the gap that we still exists even now, and we'll have to figure it out how to do it that how do we do demand creation for these all of these the factories and plants that we are putting together. And for that, we need to have those local system integrators, the OEMs, the ODMs, the product companies who should be able to say is that I need this part for this price by this time with this features, and then being able to define and drive the demand creation and probably becomes the pilot for many of the global companies to see that we have an alternative which is coming out from here, and some of the product companies have validated and enabled that. So demand, yes, exists. Is demand being created through the right so-called as ecosystem players? Not yet. We need to focus more on that.
All right. All right. Uh, how important is PSMC's involvement for technology transfer and manufacturing expertise? Because India doesn't really or doesn't yet have the indigenous fab expertise that Taiwan, South Korea, and Japan have built over decades, right? PSMC, I believe, is only partly filling that gap.
That's correct. Yeah. So all of these, whether it is fab or packaging, you need a technology provider who has done the right research and ensure that they have the details of in a fab world, we talk about PDKs, how does the device and technology look like? Similarly in packaging and others. So you have to get a lot of those technology components ready along with the machines and equipments and the capability to convert that into a physical part. So the role of these technology partners is very, very critical. They are the first one to enable the first plant or the first wafer out and all of those things. And that's where I'm bringing in the topic of saying, can we keep doing this by licensing it? Because it will cost a lot when you go and license this technology. Versus can we homegrown build it indigenously with global research partners, right? And then be able to supply saying this part of the technology we have built it and probably can be leveraged as we get into the next packaging technology, next manufacturing technology, next fab node, and all of that.
Okay. Speaking of packaging, Naveen, most of India's approved semiconductor units are in assembly, testing, marking, and packaging, rather than wafer fabrication. Now, Micron, Kaynes, CG Semi, Tata's Assam facility, packaging is essentially lower on the value chain than fab, but it is also where India has moved the fastest, as per the records. Now, would you say that packaging is a strategically valuable entry point, or is India starting at, the part of the semiconductor chain where the margins are, the thinnest and differentiation is the hardest?
Depending on how you want to see it, the way I see it is that two metrics, like one, the amount of capex required to get something started, right? And second is the complexity of that whole task to get it done. In both cases, if you look at it, there is a sizable difference in the complexity as well as the cost that is involved to do a fab versus a packaging. Packaging is something that has been proven. We have more technology partners distributed across the chip, and it probably gets us to the first place where we create a manufacturing ecosystem. And when I say manufacturing ecosystem, one is all these the chemicals, gases, and equipments, materials, and all of those things coming in. The second one is the whole discipline about manufacturing. right? That where the quality is at a much higher level than some of the quality levels that existed in other similar manufacturing areas, right? How do we ensure those qualities gets maintained and then remain in? Packaging is a good starting point for us to get into that manufacturing culture, that manufacturing skills and talent, and the manufacturing processes to set those quality levels. We are enabling through this and can get it fast. Once it is done, that move it up the value chain into a more complex, heavy capex and a significantly complex technology integration, and then start repeating that. So it has to be looked in that way, that how do we be more predictable and more successful rather than just being ambitious to say I'll go and solve the most complex problem.
All right, all right. Navin, can India use packaging to move into advanced technologies, like chiplets and 3D integration and heterogeneous packaging? Because if yes, then packaging is a beachhead. If no, it's a lower margin service industry, that competes on cost. So what is it?
Yes, it that's the whole aspiration. In fact, if you look at the Semicon 2.0, one of the area where we have said in the fab side or the manufacturing side that we would want to continue forward is that advanced packaging, move from what we call as the matured packaging that we bring in, because they fit into the India use cases of automotive, industrial, some of the telecom infrastructure, and it works well for it, right? That's what we needed. But we are also looking at saying, hey, what is the next wave coming there? So we have to keep an eye on that. And that's where the chiplets, the advanced packaging, the heterogeneous integration, and all of those coming in. So in fact, one of the vertical that we have started is called R&D, and there's already a program where we have divided the packaging related, I would say, advanced technology research among multiple academia institutes in India, and going and building from what materials we use versus how do we manage the thermal these things, and then bring all of that to be able to say that we can do the integration for a complex or an advanced packaging there. So that's a normal or a natural progression that we'll see as we move from a mature packaging into an advanced packaging for complicated use cases, whether it's primarily, I would say, data center could be the driver, but there could be others that could come in as well.
Okay, all right. Naveen, playing a bit of a devil's advocate here, what would really prevent India's packaging industry from competing primarily through subsidies rather than capability? Because subsidies, they can get a facility built, but they can't make it world class.
Correct. The subsidies is more to get started. Capabilities is what will make it commercially successful, and a longevity for it to be replicated across that. I'll come back to the same point.
Yeah.
We need to have the lead customers and the global drivers to be able to leverage those packaging plants that we are doing. We see that in one case, we have a global customer who is a partner and has got the first, I would say, packaged part from one of the plants. Similarly, the second one has a global partner as well. So the longevity is driven by saying, do we have the customers who has the volume that can be filled through this? The second one is that how we turn around the cycle time, and in which case the yield and the cycle time will come in, that how good we are with churning when the wafer comes in and then we send the packaged parts out or assembled parts out and things like that. And third, sometime we'll have to start looking at saying, what does it cost to get it, keep it competitive and sustainable from a long-term perspective. So we'll go through those three cycles.
All right, all right. Thank you for answering that, Naveen. Let me also ask about compound semiconductors, because I think it's an underreported part of the story. Now, India's approved portfolio includes silicon carbide, gallium nitride, micro LED displays, power electronics, and discrete semiconductors. Now, these are not the leading edge processor market, but they serve electric vehicles, telecom, energy, industrial systems, and defense. And India may have a more realistic path to global relevance here than in competing head-on with TSMC. So, Naveen, where do you really stand on this? Should India prioritize compound semiconductors over trying to catch up at advanced silicon nodes? And which markets create the sustained domestic demand to make these projects commercially viable?
Yes, my advice or my thought has been
Yeah.
that we should prioritize the, I would say we call it a strategic, I would say fabs or technology, specifically the compound semiconductor part of it. And then we have seen a lot of use case in India. The way the sustainability, the focus on mobility, and some of the other critical, mission critical use cases that we are seeing across space, aerospace, defense, and all of that. There's a lot of need for a power electronics and a high voltage devices and those kind of use cases coming in. So there's a local market that exists for us to leverage and then be able to support that through these fabs. And then hence there is actually a priority and a place for these fabs to come in before we really start to look into the advanced fab. Because advanced fab is not just about the capex and the technology. It is also about saying what are the use cases, right? And a primary driver is maybe a cell phone or a data center. Do we have any end users who is building those rather than assembling it here, right? And then hence, probably that could be maybe a priority behind these, I would say, the strategic compound semiconductor related fabs. And then I think the India ecosystem is acknowledging it. And we are trying to look for critical technology partners to be able to build on those technology nodes.
Absolutely, Navin. What would it really take for these projects to become exporters rather than, primarily serving subsidized domestic demand? Because export capability is the real test of whether or not these are globally competitive facilities or protected industries.
Right. And that's where we touched upon the point that the ecosystem can only be called successful if it connects globally to the supply chain. It will be false on us to think that we are creating all this locally to just create a self-sustainable and our own sovereign use case and things like that, right? Globally is where we need to go and play because that's where the value creation comes in. Semiconductor is a cyclic market. We have seen over the last 3 or 4 decades, there is something changes and then something goes up. At one time, automotive was the biggest driver, but for the last few years, we are saying is that there's a change happening on the focus on what kind of devices and what kind of electronics that goes into the car, and especially EV versus hybrid versus the traditional combustion engine. So it's going through a churn. But then thankfully, what happened was that data center came in and leveraged the market. Similarly, if you see is that even this consumer mobile and others is going through a churn if you follow some of those things. But again, a lot of, I would say, digitalization is happening and hence industrial is picking up and there has been a lot of focus on that. So while this cycle happens, this cyclic changes that happens in semiconductor, having the global exposure to a diverse technology or use cases, a diverse set of customers across the diverse geography, depending on what transition that geography is going on with respect to their digital footprint that they're doing. And that's what helps to not just ensure that you continue to run these factories in this thing, but also derive a roadmap for what should your focus be for the next technology node or the next use case.
All right. All right. Naveen, in terms of design, India has one of the world's largest semiconductor design workforces, right? Hundreds of thousands of engineers are doing chip design almost entirely for multinational companies. Now, the IP goes to Qualcomm, Intel, ARM, NVIDIA. The salary stays in India, but the knowledge and the ownership leave, right? Now, Semicon 2.0 has supported 24 chip design projects, given 105 startups and MSMEs access to advanced EDA tools, and trained, I believe, 68,000 students across 315 universities. Why is it that India's design talent has not yet produced more, I would say, globally significant chip companies, and can access to EDA tools actually change that?
So on the design side, you're right in saying that India has one of the largest designer pool that we have noticed over the decades. But when it comes to creating the Indian design startups, there has been challenges that they need to solve. What are they building? And then probably answering saying whom are they building for? The second one being is that do they have the right funds and R&D investment? And third one is that if they do it, can they scale? Because that way they can take it to the manufacturing, production, validation, testing, and then be able to do that. The I would say the bottleneck first phase was about saying we don't have the funds. Take for example the first DLI scheme was giving on an average 2 million US dollars. That doesn't cover a significant R&D expense that comes there, and it's much more. So there was some level of a, I would say, a capex limitation or a funds limitation. The second one was there is that we probably have a use case, but we don't have a customer who can use it. A lot of times, some of these people were building it for military applications or some of the other strategic applications where there's no volume. The volume comes from more larger consumer and enterprise use cases. And third one was that to take it to the production, how do we have the ecosystem where we can do a post silicon, post manufacturing, validation, assembly, testing, and all of those things. Those were some of the limiting factors. Now, funds is getting solved. We have a good VC ecosystem that's been created. We also have a government funding in Semiconductor to be much more, I would say, advanced. It does cover a basic incentives. It also covers a royalty based or a equity based incentive. So that helps reduce that barrier. The second one being the ecosystem there to ensure that I can take the product post manufacturing, post packaging to a post validation, qualification, characterization. Those capabilities are being created. The third one probably still remains saying who are the customers who will use this beyond the regular military or strategic use case into more bigger consumer parts. And hence, we need to create that demand very strongly. There was also one limitation that I think when we look at these design talent, a lot of these design talent is what we call as they can decide design based on specs defined by someone else. So in many cases, the specs was defined somewhere else, and then we were doing the design. How do we bring in those talent or the capability which is able to define the specs from the market use case and then take it there? And I think that's where there is a lot of opportunity for us to get the diaspora back, have the OC being enabled for some of these ecosystems to be accepted that they will be part of the founders and the key leaders, and then being able to push forward this design creation and product creation opportunity to go from a 24, 25 to really into hundreds.
Right, right. Navin, I also want to talk about one major hiccup here. Who will really fund expensive tape outs and successive chip iterations? Because getting a design through silicon is extremely expensive in itself. And that's where I believe most Indian chip startups hit a wall, hit a roadblock.
Correct. So that's what we call it as in many cases, what we call as an NRE, a non-recurring engineering cost. And that's part of your so-called as an R&D cost that you build in when you start planning a chip, and it includes the IP, EDA, IT infrastructure, the design talent pool, but also the manufacturing cost part of it, right? So you look at it as a total cost angle rather than distributed angle, and then go and say for this I'll get from VC versus this get from government or something like that. Right. When we have this total, let's say whatever it cost 100, then what part of it comes from government, and some of those things are just not a direct dollar value, but you have access to the EDA and the IP. And some of the other cases, probably you get support by having a subsidized fab entry point with some of the strategic partners, so that I can go through some of these partnership and be able to manage a subsidized rate, but get the manufacturing done and then move forward with that. So I don't think it's a one answer saying one particular party or somebody has to do it. We'll have to look at the program and find out the different ways of funding for the total program, and also looking at strategic priority and getting a priority at the manufacturing partners to be able to build these designs.
All right. All right, Naveen. I also want to talk about if India can build the equipment and materials layer, right? Semiconductor manufacturing depends on extraordinarily specialized machinery, chemicals, wafers, gases, substrates, right? And India imports most of this. You cannot have a resilient semiconductor ecosystem if the inputs to the ecosystem come from a handful of foreign suppliers who can be disrupted by, geopolitics, natural disasters, or policy changes. Naveen, which equipment and material categories can India realistically localize during Semicon 2.0? And also, can a semiconductor ecosystem be strategically resilient while remaining dependent on, imported production equipment?
I would look at it differently, Hunter, and I have
Okay.
said this. No one company, no one country, no one geography can own the complete supply chain for semiconductor. So for us to think that we will be able to do everything on our own from what it takes from start to end
Hmm.
is not possible. We shouldn't
Okay.
be planning that way. I think I
Okay.
credit to the government that they've been very clear
Hmm.
that we will look at it always in a collaborative way rather than doing it on our own.
Hmm.
We find in which are those geographies so that we can have strategic partnership to bring some of those which is globally acknowledged because we want the best of the technologies available to us. We'll also see is that where we can locally create some of those things and then be able to, I would say, complement it with the global suppliers and have so-called as an option
Okay.
for different technologies and all of that, right?
Mhm.
Uh, we use quartz and silica quite often. Can we do it here? Probably yes, right? Similarly, a lot of chemicals and gases we get used in pharma and other places. Can we reuse from there with the semiconductor quality? Absolutely yes. Build
Okay.
that here. But if we go into, let's say, lithography equipment, we know there are only few companies in the world who creates it. And probably we still have a dependency as long as we create with multiple partners and ensure that we have both of them. So
Okay.
I would say we want to create that as a more global ecosystem
Mhm.
and along with some of the minerals and other things to be supplied from locally and creating a complementary ecosystem.
Okay, understood. Thank you for your perspective on that, Naveen. I also want to talk about this. Okay, a fab cannot survive solely because it has been built, right? It needs sustained orders. It needs competitive pricing. It needs long-term customers. India's automotive, telecom, energy, defense, and electronic sectors could provide domestic demand, yes. But domestic demand alone may not be enough to run these facilities at the utilization rates that make them financially viable. Have the approved facilities secured enough customers to support their planned capacity? And also, should government procurement guarantee initial demand for Indian manufactured chips?
Yeah, I cannot speak on the other companies
Okay.
about what they have secured or not,
Hmm.
but believe strongly that the demand creation has to be handled in both ways. Some way, government has to probably manage the demand creation by some way of defining what kind of devices or chips or products, in which case should be procured locally and if they are, how do we ensure that we support them? Because at first order or at the first kind of a, I would say, year of operations may not be the price compatible
Hmm.
versus what it has been done. And hence you will have to probably subsidize even the buyer in terms of, if you use this, then I subsidize it. And then as you start transitioning the technology and the parts,
Hmm.
and then you can moving forward. So just like there could be some incentives for the creator, similarly there could be some subsidies for the buyer as well. Secondly, we there will be always. This is why government has come up with saying there will be strategic chips that will be defined, which gets used in Indian use cases, and will prioritize and ensure that some of these plants or the designs or the ecosystem players serves that and use it as a proof of concept,
Hmm.
ensuring that the reliability and quality gets set, and then be able to optimize the cost efficiency and start building in as they start going and chasing the commercial one. So demand creation would remain one of the most important focus strategic point for us right now to ensure that these ecosystem can survive commercially without any incentives when they are stopped after I don't know when.
Right. Naveen, a bit of a follow-up question on this. How can Indian projects win international customers on technology and quality and reliability rather than incentives? Because incentives will eventually end, right? And by then, these facilities will need to stand on their own.
Correct. Yes, that absolutely. And I think that's where we'll have to prepare that one day the incentives will end and how do we move forward? And one is to create this market creation. And then that comes through the partnership. If you look at a particular end product company, if they have been using a company A globally to build their part, they have gone through the generations of using them, and hence the quality, cost, supply chain, predictability, all has been set in. So the first challenge is that how do we transition them from that, I would say, a provider into somebody then from the India. And that's where we'll have to go and put it, either because we become an alternate supplier because there are supply chain challenges that comes in, shows the technology benefit, the maturity, and being able to ensure that we can do it at repeatable, predictable cost and cycle time. Once you do that, then the whole question is that how can you retain this across generations? And that's where you need to roadmap as well about saying, hey, for this generation, for this year and the next year, this product, this technology fits in, but I also have a roadmap. So now I can work with your R&D team to do a co-development for the next generation products and technology and enhance leverage, a faster cycle time, better cost, better quality as we work together rather than as two sequential entities.
All right, all right. Naveen, chip design talent India has, in abundance. But running a fab requires process engineers and equipment specialists and clean room technicians and yield engineers, which is, I believe, a completely different skill set from design. Now, training students on EDA tools does not produce fab operators, right? Would you say that India is training the right people for fabs and packaging facilities, or is it, is almost all the training focused currently on design?
We have been balancing both the trainings, and then let's look at just use case as well, right? We'll probably have now 12 plants or manufacturing capabilities, and let's say it doubles down to 25. Means okay, we can debate whether 25 is the right number or 100 is the right number. But if it is 25 plants, most of these plants, as you go and look around the globe, is also highly automated. So the plants, probably just the plants do not create hundreds and thousands of jobs, right? It probably creates maybe on an average some few thousands and others jobs. But what happens is that the ecosystem that comes around it, it creates a multiple level of jobs, which also fits into those manufacturing processes, technologies, handling, technician, and all of those things. What look at, we are talking about products creation and hence hundreds of chip design companies, and each one of these product creations with the amount of roles adds up to hundreds and thousands of jobs. So that's why you will see is that we will always probably have a large chunk focus on the design part of it because we also supply to the world on that talent, but then also create this ones. And that one, probably what happened the first batch, we heard a lot of stories that probably they were sent to different countries because that's where they're in front of the plants, in the machine, and with the right experts, and learning what happens through a day-to-day activity or a sequence of steps, and then learn, practice, and then come back and deploy there. But we also need what we call as a fresh talent coming out because that becomes your talent pipeline, in which case we have started doing what we call as a semiconductor manufacturing program. The IITs, SCs, and few others, even the Gujarat ecosystem, some of the other colleges, Tamil Nadu ecosystem, they have created this program which is on semiconductor manufacturing and trying to create talent that can come in and fit in there. So it has started happening there. Has it really been successful to call, saying, hey, we that we are able to generate all of those things? No.
Hmm.
But we have started in those right programs, the right curriculums, the right access to some of these nano fabs and the research fabs that we have in this academia institute to give that exposure and combine with this, I would say the people who are taken there and trained, as well as in some cases will probably move some people of Indian origin or somewhere else for the first few years, for the first node, for the first delivery and all of that, so that we can move the, I would say, execution forward while we create a significant talent to multiply and start doing multiple products, multiple technologies, and multiple plants.
All right, Naveen. Thank you for that. Naveen, the upcoming Semicon India 2026 event takes place from September 17 to 19, 2026, I believe at the Yashobhoomi. Do you have any exclusive updates about the preparations going on? Any insight that you might have for our viewers who have tuned in right now?
Yeah, it's coming up really well. The exciting thing is that it's a 3 day packed. We are covering those 6 verticals of Semicon.
Okay.
There's a lot of CEOs who have been reached out. So CXO and CXOs, they have confirmed their participation.
Okay.
We'll have PM roundtable as well as the Honorable Minister roundtable with those leaders. But the exciting thing is that the 95% of the exhibit booth space is already sold.
Oh.
And then there's a lot of others who are already in the queue asking for more space and additional space and more companies coming in because they want to come and showcase in the India ecosystem about their capabilities and how do they fit into that. So we also have special areas for how do we create the talent. We have a startup booth and ecosystem that's coming in. We have hackathon coming from students so that they get to exchange some of the hands-on learning. We have a special session that we are creating where we bring leadership for women, leadership in different areas of design versus manufacturing, and being inclusive of the complete ecosystem. So it's coming up really well, and 3 days we'll have what we call as both the acknowledgement of the how ecosystem is growing, also some level of celebration that how first step has yielded something and how the focus on second step needs to be accelerated.
That sounds fantastic, Naveen. Exciting times ahead, right? Exciting times ahead. All right. In the interest of time, Naveen, I do have to wrap the segment, but I have one final question before I let you go. With rupees 1.27 lakh crore committed and India moving decisively from ambition to execution, what are the warning signs over the next 3 years that would tell you the strategy is falling behind? What would you be watching?
Weak, I would say, weak domestic demand creation for us to be able to get started. Limited supplier localization, because that drives a lot of efficiency and cost and all of that. And I would say insufficient focus or an outcome in terms of innovation, IP creation, and hence contributing to the product. So I would say those three are the warning signs to watch out for.
All right, all right. And while I did say that this was the last question, I do have another question for you, Naveen. By 2030, what would prove that India has built, a real semiconductor industry and not just a financed one?
Yeah, I think we'll take for granted that the fabs and OSATs will be operational, but a globally competitive, what I call as a packaging capabilities, that's important. A strong supply chain participation that's happening, and I would say a measure of how much semiconductor exports that we have started doing it. And somewhere this will probably show us that there's a recognition that we are a trusted and equal partner in the semiconductor value chain rather than just being a talent factory.
All right, Naveen. Thank you so much for your time, Naveen. It's been a very exciting conversation, very, very insightful one at that. And for everybody who has tuned in, ladies and gentlemen, I would say India has moved past the point where, the semiconductor conversation is theoretical. The money is committed here. The facilities are being built. The question now is whether they connect into an ecosystem where design feeds manufacturing and manufacturing feeds packaging and packaging feeds customers, and the customers fund essentially the next generation of design. That connection is what makes Taiwan a semiconductor superpower, and what makes every other country's semiconductor ambition eventually fall short. Whether India threads that needle is, I believe, the most important industrial question this country will answer the next decade. So, Navin, thank you so much for your time. And ladies and gentlemen, thank you for watching. Thank you for tuning in. I'm Antara. This is Point Break. I'll see you again next episode.